Hey everybody, what's up? It's Papa Bale. Welcome to the channel. Uh, well, what we're looking here is the ability of the pulse motor. We're looking at a pulse motor here. Actually, we're looking at two pulse motors and the light being generated all from different parts of the circuit here. Alright, so we got our two drive coils, one here and one there on our main pulse motor. And here's the one transistor, and the other one is right there. And then we have our second pulse motor hooked up to our first pulse motor circuit. So this green wire right here is giving this other one its power. And that is just moving at fantastic speed. And then our series circuit is powering the light. So that's something totally different from any of the other stuff going on here. A little bit of transformer power, a little bit of series circuit power. It's enough to light up the light. And that's all that really matters, is it can turn it on. It takes more than a little bit to turn it on, so I'm happy with that. This pulse motor, as you can see, is going pretty fast. It's at 3.7 volts in. We don't have anything else hooked up to it currently. So it's purely kinetic energy, but as you can see, it's quite a bit of kinetic energy for 3.5 volts. So I started doing this with the idea that I would, be making my discs move without me moving them. That was my goal. And so now that I've met my goal and surpassed my goal and done everything about my goal, what do I do now? Well, I got something on the table. I'm gonna get cracking on that. Heck yeah, man. So we're talking about making a coil with a very large EMF, large and strong EMF, and then having some pickup coils surround them. So it'll be like a cascading charge effect. So you'll have 3 middle coils, and you'll have 3 rings of pickup coils around each coil, and each ring will fire off the next EMF coil. So how do we do that? How do we make it so it picks up and it has enough, voltage or energy, power to fire off the next coil? It's got to be kind of right there in the middle, like a 38. I'm really thinking 38 would do good. And or a 42, but I can't work with 42 that well. Look at that thing go, man. That is freaking awesome. For that's how much volts are going in. 3.78. And then the second drive coil for the main pulse motor, which is the one on the top, we got 6.16 going into that one, and half an amp is going into that as well. Awesome. So Turn the light off. Let me get some voltage. What I think I'm going to do is I'm going to hook up this coil down here on the ground. Same way I hooked up this coil to the other side over here. Should be an interesting test. It's not like it needs it. That's not why I'm doing it. I'm doing it because it's a coil that I have laying around, and I'm gonna use it somehow. She's phenomenal, dude. I love having the second pulse motor moving on the same power supply. That's awesome. Voila. So fun. Especially when things work. And they work on like the first try, you just move it a little bit and everything starts to move. That's the way I like it. And that's the way this is right now. So I guess I'll keep going for a little while longer. Alright, let's turn it up a little bit. Just a little bit. Now we're at 5 volts in. Unbelievable, dude. That is freaking fast. Unreal. I'm just waiting for something to fly off of that. Instead of waiting for something to fly off of it, let's turn it down. You know, before we turn it down, let's get a tack reading. $2,000 RPMs. Freaking amazing. Wow, that says 1700. It's hard to figure it out because that tinfoil is a little fat. So now the power is totally cut because that's on a ceramic bearing that's going to spin for quite a while. But yeah, this is Papa Bale signing off, saying he's still having fun, and that's what it's all about for him. Alright, thank you very much. Peace out. Bye now.